Hello everyone, welcome to the course on Introduction to Electric and Hybrid Electric Vehicles. So dear learners, in today's lecture we will discuss some important aspects related to electric vehicles. So in today's lecture we are going to discuss about the safety standards and protocols which are related to electric vehicles. After that we will look into the maintenance tips for your electric vehicles, and at the end of this lecture we will discuss about the recycling of used electric vehicle batteries. So learners, let's start the lecture. So if we talk about the safety standards and protocols, it is very much necessary for the things which we are using in our day-to-day life, and as we know, the automobile sector is a part of our life and we are heavily dependent on these electric vehicles and the IC based vehicles. So the safety standards and protocols for electric vehicles are essential to ensure the safety of both users and the surrounding environment. These standards address various aspects of the EVs, which includes the design, the construction, the battery management and the charging infrastructure. So let us discuss about some of the key safety standards and protocols. So first of all, we will discuss the safety related to the battery. So in the battery section, first of all we have the thermal management. So the EV batteries are designed with systems to manage heat and prevent overheating, which could lead to thermal runaway, a dangerous condition where the battery catches fire or explodes. So in this thermal management, in our day-to-day example, we are seeing that normally when we are charging the electric vehicles, they catches fire. So we will hear some of the news like this particular EV is plugged in the charging at the night time, and after connecting to the charging point it gets heated up and the battery get exploded. So ultimately it catches the fire. So the thermal management is a very important aspect in the charging of batteries. So OEMs are putting a huge amount of their money and investments to manage the thermal properties of the battery. So they are using some of the techniques like we see in this Chetak electric vehicle, there is a fan which is connected to the battery. So once the heating or the thermal level of the battery rises, the fan starts rotating and it cools the battery during the charging process. So these are some of the methods which can be used for the cool down of batteries during the charging process. So this comes under the thermal management of the battery. Now the battery management system. So battery management system stands for the BMS. So the BMS ensures the battery operates within safe temperature voltage and current limits, preventing overcharging, deep discharging and short circuits. Next one is impact resistance. So the EV batteries are designed to withstand collisions and impacts with protective enclosures to prevent physical damage. So these are certain points which kept in mind for the safety of the battery. Likewise, recently we have witnessed a LPG based bike. So in that LPG based bike, the weight of the bike is very much heavy, and out of the whole body weight, the main weight is of the CNG tank. So they have created the CNG tank in such a manner that during the collision or during any uncertain event, the cylinder remains intact. Means in any case the cylinder should not be break or it should not be get damaged. So if the cylinder gets damaged, it will create a explosion or it will create a major accident. So these are some of the safety standards which needs to be kept in mind while we are designing any new kind of fuel or any new kind of vehicle. So these points are related to the batteries. Now second, we will look into the charging standards, the standards and protocols related to charging standards. So in this, the first one is IEC 61851. So this standard covers electric vehicle conductive charging systems, which includes the connectors, plugs and charging stations. It ensures safe charging and protects user from electrical hazards. So electrical safety is a major concern in case of electric vehicles, as there are major number of electrical components. So electrical safety is very much important for the user. Now next one is IEC 62196. So this specifies the charging couplers for EVs, defining different types of plugs and sockets, ensuring interoperability and safety between different vehicles and charging stations. As we have discussed in the charging standards lecture, what are the different couplers, like for different levels we have different types of connectors. For AC chargers we have some different types of connectors. For DC chargers we have some certain connectors like the CHAdeMO, the CCS. So these are different charging standards, and based upon these charging standards we have different types of sockets and plugs for the charging circuit. So this comes under the IEC 62196. Now we have the ISO 15118. So this standard focuses on communication protocols between EVs and charging stations, allowing for secure automated charging and the exchange of information. So like we all know, there is a proper communication between the charger and your EV battery. So to establish a proper channel of communication, this ISO 15118 communication protocol has been designed. This includes the payment methods and the grid management. Now next is the protection against overcurrent. So the charging systems are equipped with safeguards to prevent electrical overcurrent, which could damage the battery or electrical components. So this comes under the overcurrent protection. Now next is crash safety and fire protection. So in day-to-day life we are witnessing that during the charging process or during the usage in summertime, the battery catches fire. So the fire protection of the batteries or for the EVs is an important aspect when the user is using the electric vehicles. So in this UN R100, so this is a global regulation addressing the safety requirements for the electric powertrain, including safety against electrical shocks, battery integrity and post-crash safety protocols. So this all things comes under the UN R100. Now next is ISO 6469. So basically this provides guidelines for EV safety, addressing potential hazards such as electrical shock, fire and leakage of hazardous materials from the battery. As we all know, the battery is nothing but a chemical composition of various chemicals stored in a cell. So there are the hazardous materials which can be leaked from batteries. So we have to ensure that the battery is properly sealed. So for that we have this ISO 6469 standard, which deals with the protection of batteries. Next is fire suppression systems. So some EVs are equipped with built-in fire suppression systems to control fires resulting from battery malfunctions or collision. So this fire suppression system is nothing but a cooling mechanism which is provided for the battery. So, right now some of the manufacturers are using the liquid cooled batteries. So, what they are doing? They are propagating a liquid fluid around the batteries, so that the thermal energy of the batteries can be stored in that liquid and it can be disposed to the atmosphere. So, these are the certain measures the manufacturers are keeping in mind for the safety of battery and for fire protection. Now, next is the electrical safety. So, electrical safety comes with the high voltage isolation. So, as we all know, as we have to improve the range of the electric vehicle, we have to use the more number of batteries, means the capacity, the power rating, the voltage rating should be high enough to cater that particular range it is offering. So, it is required for the high voltage isolation for the EV batteries. So, EVs use high voltage system. So, standards ensure that components are well insulated to protect users from electric shocks. Next is ground fault detection. So, systems in the vehicle detect ground faults and automatically shut down power to prevent electrical hazards. Next one is emergency cutoff systems. So, in case of any emergency or in case of the accidents, EVs are designed with emergency cutoff mechanism to disconnect the battery and avoid electric shocks to passenger and first responders. So, these are the preventive measures or the safety measures related to the electrical hazards. Now, next one is the electromagnetic compatibility. So, electromagnetic compatibility includes the IEC 61006. So, basically this ensures that EVs do not emit excessive electromagnetic interference that could affect other devices and ensures EVs are immune to EMI from external sources. Next one is CISPR 25. So, this specifies the limits of radio disturbances for vehicles, protecting onboard electronics from interference. Now, next one is the safety protocols related to the autonomous driving and driver assistance. Like we all know, we are as we are progressing, we are going into the autonomous part of the automobile sector. So, in this we have this ADAS level 1, level 2, level 3. So, likewise based upon the autonomy, these levels are decided. So, there are certain protocols related to this autonomous driving also. So, this includes the ISO 26262. So, this standard addresses the functional safety of electrical and electronic systems in vehicles, especially critical for autonomous and semi-autonomous EVs. As we all know, the autonomous feature uses these various sensors, and these sensors are operated with the electrical supply. So, electrical supply and also the electronic system. So, safety standards is very much necessary to operate these sensors in a right direction. Next one is SAE J3016. So, this defines the different levels of driving automation, ensuring that advanced safety features are reliable and fail safe. Now, the next one is about the vehicle testing and certification. So, this includes the famous global NCAP ratings, so which stands for New Car Assessment Program. So, basically this NCAP rates the EV safety in crash tests and other safety parameters to ensure they meet stringent safety requirements. So, this GNCAP tests various vehicles in terms of the strength, in terms of the passenger safety. So, all these parameters are tested in this global NCAP testing. So, next one is UL 2580. So, this covers electric vehicle battery safety standards addressing electrical, mechanical and environmental tests that EV batteries must pass. Now next one is the safety during recycling and disposal. So ISO 14001 deals with the recycling process. So basically it focuses on environmental management, ensuring that EV battery recycling and disposal processes adhere to environmentally safe practices. Next one is battery directive. So the European regulation that ensures the safe disposal and recycling of electric vehicle batteries, addressing environmental and safety concerns. So these standards and protocols ensure that electric vehicles meet high safety requirement both in operation and manufacturing, providing users with reliable and safe transportation option. So learners, next we are going to discuss about the maintenance of electric vehicles. So as compared to the traditional ICE vehicles, the maintenance is simpler because EVs have fewer moving parts and no engine oil. However, regular maintenance is still essential to ensure optimal performance, longevity and safety. So here are some of the key EV maintenance tips. So first one is the battery care. So in battery care, maintain optimal charge levels. So in terms of the charging level maintenance, we have to avoid letting the battery drop below 20% or charge it to 100% too often, as this can shorten the battery's lifespan. Ideally, keep the charge between 20% and 80% for regular use. Minimize fast charging. So we do not have to use the fast chargers in regular basis. So why it is so? While fast charging is convenient, frequent use can generate excessive heat and degrade the battery over time. So better to use slower level 2 charging whenever possible for daily needs. Next one is avoid extreme temperatures. So if possible, park the EV in a garage or shaded area to avoid exposure in extreme heat or cold, which can affect the battery performance and health. Next one is regular software updates. So ensure that the vehicle software is up to date, as manufacturers often release updates that improve battery management and efficiency. Next one is tire maintenance. So we have to check the tire pressure monthly, as underinflated tires can reduce efficiency and cause uneven wear. And also we have to follow the manufacturer's recommended tire pressure. Also we have to check the tires, as the EVs are carrying more weight as compared to the ICE based vehicles. So tire wear can be more pronounced. So rotate the tires in every 5000 to 7500 miles to ensure even wear and extend their lifespan. And next one is the wheel alignment. So if you notice uneven tire wear or the vehicle pulls to one side, get the alignment checked. Proper alignment enhances efficiency and the extends tire life. Next one is brake system maintenance. So as we all know, the EVs uses the regenerative braking, so which reduces wear on traditional brakes. However, the brake pads and discs should still be inspected regularly, as they can corrode if not used frequently. Next one is the brake fluid. So check the brake fluid level as per the manufacturer's recommendation and replace it every 2 to 3 years to ensure the braking system operates effectively. Next one is the cooling system. So battery cooling system, as we have already talked about, that some EVs are equipped with liquid cooled batteries, which ensures that the coolant is checked and replaced according to the manufacturer's service schedule, typically every 4 to 5 years. Next one is the inverter and motor cooling. The electric motor and inverter may also have cooling systems that need periodic checks to prevent overheating. Next one is the software and electronics. So, as this software and electronics plays a very important role in case of EVs, as there are continuous updation going on regarding the microprocessor control. So, this software and electronics plays a very important role in the proper or the overall operation of an electric vehicle. So, the software updates, which is the manufacturer frequently releases over the air software updates to improve vehicle performance, battery management and safety features. So, we have to check it regularly for the updates. Next one is the onboard diagnostics. So, pay attention to any warning lights on the dashboard, as they may indicate issues with the battery, electric motor or other electronic systems that require attention. Next one is the cabin air filter. So, the EVs, like traditional vehicles, have cabin air filters to keep dust and pollutants out of the interior. So, change this filter in every 12,000 to 15,000 miles or as per the recommendation of the manufacturer. Suspension and the steerings. So, although EVs have fewer mechanical parts, the suspension and steering components should be checked periodically for wear, especially because of the extra weight of the battery. Next one is the checking the charging equipment. So, we have to inspect the charging cable regularly, as for the any kind of wear or damage, and ensure that the connectors are clean and free of debris. We have to keep the charging port clean. So, check the vehicle's charging port for dust, debris or corrosion which could interfere with the connection or charging efficiency. Next one is the fluids. So, the fluid washers for the windshield, we have to check its level regularly and top it off as needed. Next one is the transmission fluid if applicable. So, some EVs have transmission with gear oil or transmission fluid. So, we have to check the transmission fluid, or we have to consult the owner's manual for the correct maintenance schedule. Next one is the cooling fluid. So, as mentioned earlier, maintain proper levels for battery and inverter cooling system. Next one is the drive system inspection. So, check the drive motor components, as the electric motors requires minimal maintenance, but the reduction gearboxes and other associated components should be inspected periodically. Axle and suspension components. As part of regular maintenance, ensure that the axles, suspension and wheel bearings are in good condition, especially if driving frequently on rough roads. Now, next one is the exterior care. So, in case of exterior care, we have to care for the paint and body care. So, regular washing and waxing can protect the exterior from dirt, pollutants and road salts. And also we have to check about the seals and gaskets. So, ensure that door seals and window gaskets are intact to prevent water leakage or air draft. And also we have to check for recalls. So, we have to keep an eye out for any manufacturer recalls related to your EVs, as recall often involve safety critical components including battery systems, charging mechanism or software issues. So, by following these EV maintenance tips and adhering to manufacturers recommended service intervals, we can ensure the long term health of the electric vehicle while maximizing the performance and safety. So, this is regarding the maintenance of the electric vehicles. Now, we will discuss a very important topic which is related to the recycling of used batteries. So, the recycling of EV batteries is crucial for minimizing the environmental impact, recovering valuable materials, and ensuring that hazardous substances are handled safely. So, EV batteries typically are of lithium ion, contains material such as lithium, cobalt, nickel and copper that can be reused in new batteries or other applications. So, we will discuss about a step-by-step guide to process the recycling of EV batteries. So, first of all, we will have the collection and transportation. So, end of life identification. So, once an EV battery reaches the end of its useful life, which is typically between 8 to 15 years, it is removed from the vehicle. The battery's capacity may have degraded, making it unsuitable for driving, but it can still have other uses or be prepared for recycling. So, next we have the safe transportation. So, the used EV batteries must be transported to recycling facilities according to strict safety guidelines, as damaged or improperly handled batteries can be hazardous due to their chemical content and potential for fire. Next one is battery evaluation. So, testing for secondary use. Before recycling, some batteries are tested to see if they still have enough capacity for secondary applications. Batteries with sufficient remaining capacity can be repurposed for less demanding uses such as energy storage in homes or commercial facilities. It is also called as second life batteries. Next one is deactivation. So, the batteries destined for recycling are discharged to minimize the risk of short circuits, fires or explosions during the disassembly process. Disassembly, manual or robotic disassembly. So, the battery pack is disassembled to separate the different components. This involves removing the battery modules, individual cells and associated electronics, example wiring, cooling systems and casings. Now, the separation of materials. So, the battery cell are further broken down to separate valuable materials such as lithium, cobalt, nickel, aluminum and copper. Some components like the outer casing and wiring are typically easier to recycle, while other require more intensive processes. Now, next is the material recovery, recycling process. So, two main processes are used to recover material from EV batteries. First one is the pyrometallurgy, which is also known as smelting. So, in this process, batteries are heated at high temperature in a furnace. The heat causes the metals which are cobalt, nickel, copper to melt and separate from the battery's other components. This method is effective in recovering metals but less efficient for recovering lithium and is energy intensive. Next process is hydrometallurgy, which is also known as leaching. So, this method uses chemical solutions to dissolve the materials in the batteries. The metals are extracted by applying chemicals to selectively separate them. Hydrometallurgy is often preferred because it can recover a wider range of materials, including lithium, at a lower energy cost compared to pyrometallurgy. direct recycling. So, an emerging method, direct recycling, involves carefully separating and preserving the battery's cathode and anode materials so they can be reused directly in new batteries with minimal processing. This method has the potential to reduce the cost and energy required for recycling. Now, next one is refinement and reuse, material refining. So, after the metals are extracted, they undergo refining processes to purify them for reuse in manufacturing new batteries or other products. Reuse in manufacturing. So, the recovered metals such as cobalt, nickel and lithium can be reintroduced into the supply chain, reducing the need for mining new materials. Recycled materials are used in the production of new EV batteries, electronics or other industries. Next one is recycling facilities and technologies. So, we have the specialized recycling centers. So, EV batteries require specialized recycling centers equipped to handle their size, weight and chemical content. Not all recycling facilities are equipped to handle EV batteries. So, dedicated centers are critical. Next is the closed loop recycling. So, some companies aim to create a closed loop system where the materials recovered from old batteries are reused to make new batteries, reducing the need for new mining and production. Next one is environmental and safety regulations. So, compliance with regulations. Recycling facilities must adhere to strict environmental and safety regulations to handle toxic materials, example lithium and cobalt, and prevent air and water pollution. Next one is the handling hazardous materials. So, EV batteries contain hazardous chemicals such as electrolyte solutions that must be handled safely to avoid environmental contamination. Now, next is the second life application. So, before a battery is recycled, it may be repurposed for second life applications. So, the second life applications are energy storage system. So, used EV batteries with reduced capacity for driving can still serve as stationary energy storage systems for homes or industrial facilities. They can store energy from renewable sources such as solar or wind, providing grid stability or backup power. Grid stabilization. So, utilizes the use of second life batteries for stabilizing power grids by storing excess energy and releasing it during peak demand times. Next one is the research and innovation. So, improved recycling methods. So, research continues to improve recycling efficiency, reduce cost and increase the recovery of valuable materials. New technologies like direct recycling and automation in battery disassembly are being developed. Battery design for recycling. So, manufacturers are increasingly designing EV batteries with recycling in mind. This include using fewer hazardous materials, modular designs for easier disassembly and using materials that are easier to recycle. Next one is the consumer role in battery recycling. So, return programs. So, consumer should return EV batteries to authorized collection centers, dealership or recycling facilities. Many automakers and battery manufacturers offer take back programs to ensure batteries are properly recycled. Educating the public. So, consumers need to be aware of the importance of recycling EV batteries and the dangers of improperly disposing of them in landfills, where they could leak toxic chemicals. Now, the recycling of EV batteries is essential for sustainability, reducing environmental impact and conserving valuable resources. While the process is complex and still evolving, efforts are being made to improve the efficiency of material recovery and minimize waste. So, developing better recycling technologies and second life applications will play a crucial role in making electric vehicles even more environmentally friendly. So, dear learners, in today's lecture we have discussed about the safety and protocols for the electric vehicles and the maintenance tips and a very important topic of the recycling of electric vehicle batteries. So, dear learners, thank you for your patience and we will meet in the next lecture with some more topics. So, till then, a happy learning. Thank you.